Micron's G9 NAND SSDs, setting the pace for AI, cloud, and the next era of data infrastructure. Micron's introduction of its G9 NAND-based SSD portfolio marks a decisive moment in the evolution of data center storage. As AI workloads accelerate and cloud architectures scale to unprecedented levels, the industry faces a widening gap between compute capability and storage throughput. Micron's 9th-generation NAND technology deployed across the new Micron 9650, 6600 ION, and 7600 SSDs directly targets this bottleneck, delivering breakthroughs in performance, density, and efficiency that reshape what modern infrastructure can achieve. The Micron 9650 PCIe Gen 6 performance arrives. At the top of the portfolio sits the Micron 9650, the world's first PCIe Gen 6 data center SSD. Its purpose is clear: eliminate storage bottlenecks for the most data-hungry applications, from LLM training to vector databases and GPU-accelerated analytics. With sequential read speeds reaching 28 GB per second, roughly double the performance of leading PCIe Gen 5 drives, the 9650 sets a new bar for SSD throughput. This leap is powered by Micron's G9 TLC NAND, featuring a 6-plane architecture and per-die I/O speeds of 3.6 GB per second. The drive also delivers up to 5.5 million random read IOPS and up to 900,000 random write IOPS, ensuring that highly concurrent workloads such as TensorFlow, PyTorch, Rapids, and GPU direct storage pipelines are serviced with minimal latency. Offered in capacities from 6.4 TB to 30.72 TB and in both Pro 1 DWPD and Max 3 DWPD endurance models, the 9650 is engineered for both performance and durability. Despite its speed, the 9650 is optimized for performance per watt and supports advanced cooling, including liquid cooling options, making it well-suited for dense AI servers. Its arrival also aligns with next-generation GPU platforms such as NVIDIA's Rubin-based systems, which support PCIe Gen 6 links. In effect, Micron is seeding the ecosystem ahead of competitors, enabling compute platforms to operate at full potential. The Micron 6600 ION, redefining capacity at cloud scale. If the 9650 is about raw speed, the Micron 6600 ION is about density and cost efficiency. Built on Micron's G9 QLC NAND, it becomes the highest capacity SSD ever announced, with up to 122 TB in the E3.S form factor and a planned 245 TB in E3.L, nearly a quarter of a petabyte on a single drive. This density has profound implications. Rack-level consolidation: a 2U server populated with 40 E3.S drives can reach 4.88 PB of storage. Space savings: storing an exabyte requires 7 fewer racks compared to conventional U.2 SSD deployments. HDD displacement: a single 122 TB drive can replace 3 36 TB HDDs while consuming a fraction of the power and delivering vastly superior latency and IOPS. In large-scale AI environments, replacing HDDs with 6600 ION drives can eliminate up to 25,000 nearline hard drives per exabyte, dramatically reducing power consumption, floor space, and operational complexity. The 6600 ION is designed for read-heavy workloads such as data lakes, AI training corpora, and content repositories. With less than or equal to 0.3 DWPD endurance, it prioritizes cost per terabyte and density over write endurance, making it a compelling alternative to spinning disks while maintaining enterprise-grade reliability and NVMe/OCP compliance. The Micron 7600, the new mainstream workhorse. Rounding out the portfolio is the Micron 7600, a PCIe Gen 5 SSD built for broad adoption across cloud and enterprise environments. It replaces the popular 7450 and 7500 series, now upgraded with G9 TLC NAND and NVMe 2.0 support. The 7600 delivers up to 12 GB/s sequential reads and 6.5 to 7 GB per second sequential writes, up to 2.1 million random read IOPS. Class-leading latency and QoS, maintaining sub-1 millisecond latencies at 99.9999% QoS even at QD256. 55 to 67% lower read latency than competing Gen 5 mainstream SSDs under mixed workloads. These characteristics make it ideal for OLTP databases, AI inference, cloud instances, and edge deployments where consistency and predictability matter as much as peak performance. With strong performance per watt and enterprise-grade security including SPDM 1.2, TCG Opal 2.02, and CNSA 2.0 support the 7600 is engineered for reliability at scale. Micron's G9 NAND portfolio is more than a product refresh, it is a strategic declaration. By moving its entire data center SSD lineup to 9th generation NAND, Micron delivers higher performance, higher density, and better efficiency across every segment of the market. The 6-plane parallelism of G9 TLC powers the 9650's record throughput. The bit density advantages of G9 QLC enable the 6600 ION's unprecedented capacities, and the latency improvements of G9 TLC elevate the 7600's consistency. For cloud providers and AI infrastructure builders, the message is clear: the future of storage is faster, denser, and more sustainable. With the 9650, 6600 ION, and 7600, Micron is not merely keeping pace with industry demand, it is setting the pace for the next decade of data center innovation.